This is a video about sketching derivatives, or the graphical representation of slope functions. And before we begin, it might be useful to just review a little bit of vocabulary first of all to do with functions. So first of all, here we have a sketch of just a linear function. Notice that this function, this line, is always sloping up. So the slope is always positive, and we can say the function is increasing. So here we have a second line. Now this line is always sloping down. So the slope is negative and the function is decreasing. And both of these are pretty straightforward. The first one is increasing the whole time. The second one is decreasing the whole time. But we can have functions with a bit more variation in them. So now we have a slightly different proposition. This time we've got a parabola. And we can see that in part of our diagram, the function is sloping down. But in part of the diagram, it's sloping up. So over here on this side, the function is sloping down, it's decreasing. But on this side, it's sloping up. So it's increasing. So now where does the change occur between decreasing and increasing? Well, the change happens at this point here, the lowest point, the minimum point. You might remember from maximum and minimum points, sometimes these were called turning points. And this is the reason why. The maximum or minimum points are the points at which a function stops sloping down and starts sloping up, or vice versa. And so turning points will be very important when we are sketching derivatives in a moment. Sticking with the vocabulary review for one more minute, let's just have a look at this coordinate plane. And let's just remind ourselves that this region above the x-axis is the positive region of the graph. And it's the positive region of the graph because it's the part of the graph where the y values are greater than 0. And remember again that y might also be called f of x. So the positive region is where f of x is greater than 0. And again, it's above the x-axis. We also have the region below the x-axis. So this is the negative region of the graph where y is less than 0. And that's the same as saying that f of x is less than 0. So if at any stage later on in this video you're a little bit confused with what I mean by increasing or decreasing, or positive region or negative region, then go back to the start of the video, this section here, and remind yourself of that vocabulary. So let's have a look at an example now. The question is to sketch the derivative of this function. Now, when making decisions about what the derivative will look like, it's important to realise that whenever the function is increasing, the derivative will be in the positive region of the graph. And on the other hand, if the function is ever decreasing, then the derivative is going to be in the negative part of the graph. One helpful trick when sketching the derivative is to start off by drawing an xy plane directly below the function that you already have and try to keep your y-axis in line with the existing graph. Just like this. So I've put an extra xy plane directly below the one that I already have for my function. So I'll have the function in this graph and I'll have the derivative in this graph. So like I said, it's all about whether the function is increasing or decreasing. So let's have a look at this function. You can see it's a linear function. It's sloping up the whole time. And it's only increasing. It's not decreasing anywhere. So since the function is increasing, my derivative is only going to be in the positive region of the xy plane that I've drawn down here. And the positive region is just the region above the x-axis. Now notice too with my linear function that its slope is always the same. So it's not deviating, it's always going at the same angle. So that means that its derivative is going to be a constant. And so its derivative is going to be a horizontal line in the positive region of the plane. And this is always true for any linear function that is increasing. Notice that I haven't put any values on my y-axis. That's because I'm just sketching. I'm not trying to draw an accurate graph. I'm just trying to get an idea of where the derivative would be located on the xy plane. So let's have a look at a second example. Again, I've got a linear function and I want to sketch its derivative. So again, a good first step is to draw an xy plane directly below the function that lines up with the y-axis. Okay, so I've done that, and now I'm going to have a look at my function, and I'm going to figure out whether it's increasing or whether it's decreasing. Now it's pretty clear that this linear function is sloping down. So if it's sloping down, that means the function is decreasing. And if the function is decreasing, and you can see here it's only decreasing, then I should be focusing on the negative region of my graph for the derivative. And of course that negative region is the region below the x-axis, which is just this section down here. Now just to observe before I draw anything that, like before, because it's a linear function, it's decreasing and it's always decreasing at the same rate. So the slope of the derivative is going to be a constant. And so I'm drawing a horizontal line in the negative region of the graph. And again, this will always be the exact same for every decreasing linear function. It will always be a horizontal line in the negative region of the graph for the derivative. Okay, so let's have a look at a slightly more interesting example this time. So here I've clearly got a parabola, which is just the graph of a quadratic. So I need to have a look at my function. I need to identify whether it's increasing or decreasing and where that's happening, and then I want to sketch the derivative. So as highlighted, the function is decreasing to begin with. And then on this side, it's increasing. And where does the change between the two states happen? Well, it happens at this point here, the turning point. So like in the previous examples, I've drawn an xy plane directly in line with the existing one so that I can line my derivative up with my function. That was less important in the last two examples, but it's quite important now, because the first thing that I want to do is I want to make a note of where the transition from decreasing to increasing occurs. Now notice that decreasing would be in the negative region, so below the x-axis. Increasing would be in the positive region, so above the x-axis. And of course, what happens between the negative and the positive sections? Well, the x-axis is the dividing line. So what I want to do is I want to line up the turning point with where my derivative crosses from one region to the other. So in practice, what this means is we highlight our turning point, we drop a line from that to the x-axis of the derivative sketch. And then in this case, as I can see, the first portion of my function was decreasing, which means it should be in the negative region. So down here, moving towards this point. And then the second portion of my graph was increasing, so I'm moving into the positive region. And so this is how my derivative will look, going from the negative region to the positive region and passing through the x-axis directly in line with the turning point. Here's another similar example. Again, I've got a parabola. Again, that's just the graph that represents a quadratic. In this case, obviously, it will be a minus x squared quadratic. And I want to sketch its derivative. So I've begun by drawing underneath an xy plane and the y-axes line up. Next, I look at my function and I identify whether it's increasing or decreasing and where. And I can see that it's increasing in this region and decreasing on this side of the graph. And of course, the turning point is where the change between increasing and decreasing occurs. So I'm going to mark that turning point. Now let's remember that where the function is increasing, the derivative should be in the positive region. And where the function is decreasing, then the derivative should be in the negative region. And of course, the turning point is between the positive and negative region. It's just going to be on the x-axis. So just like before, I'll take my ruler and I'll drop a line from that turning point to the x-axis of the derivative sketch. And I'll mark that point in. And again, this is really the purpose of having my two diagrams lined up, having the y-axis lined up in order to be able to line up the turning point with this point on the x-axis. Okay, now so let's just recap again. Increasing means positive region, so I want to be in the top part of the graph originally, and then decreasing means the negative region, so I want to end up in the bottom. And so I'm coming in from the left and I'm drawing a line that goes through this point in the increasing region and then down into the decreasing region. So increasing, positive region, decreasing, negative region. And this is the sketch of my derivative. Okay, so a bit more interesting again. Here we have a cubic function, and you can see it's going down and up and down, so it's changing a good bit between increasing and decreasing. And since I want to sketch the derivative, I have my xy plane drawn in directly below that, and again the y-axes are in line to make things nice and easy for me. So I start off by looking at my function and identifying where it's increasing and where it's decreasing. So initially it's decreasing, and then it reaches a turning point, after which it's increasing, but then it reaches a turning point again, and then finally it's decreasing. So let's remind ourselves, decreasing means negative region, and then increasing means positive region, and then decreasing means negative region. So I'm going to be beginning with my derivative in the negative region, moving up into the positive region, and then back down to the negative region. To figure out where that's going to happen, I'm going to start off by dropping a line from my turning points to the x-axis of the derivative sketch. So I'm doing that for my first turning point and for my second turning point. So now, like we said, we are decreasing, so negative region, and then increasing, positive region, and then decreasing, negative region. And so my derivative will look like this. You can actually see that the derivative of cubic is a quadratic. Here's one last example. So I have my function. Again, I can see it's cubic. So I won't be surprised to expect a quadratic then for my derivative. But how is it going to look? Okay, so I'm going to start by identifying my increasing and decreasing parts of my function. So this time around the function starts by increasing, and after a bit it reaches this turning point, and then it changes from increasing to decreasing. But then it reaches another turning point, and after this turning point it's increasing once more. Okay, so I'm going to take my ruler and I'm going to drop a line from each of the turning points down to the x-axis of the derivative sketch. So I've done it for the first turning point, and then for the second turning point. So now I know where the derivative is going to go through the x-axis. So now I have to just figure out, is it going to be in the positive or negative regions of the graph between those? So let's have a look. So first of all, I'm increasing. Okay, increasing means I'm in the positive region in the derivative. So positive region is up here. And then my function is decreasing. So decreasing means the negative region. So when it's decreasing, which is between my turning points, I'm going to be underneath the x-axis. And then once it gets past that second turning point, it's increasing again, so back up into the positive region. So how is my derivative going to look? So it's going to be in the positive region, down into the negative region, back up into the positive region again. Keep it nice and curved. It is a quadratic after all, the derivative. It shouldn't have any sharp corners or points. And a nice U shape in this case is what I end up with. In some questions, you may be given a function and then several possible derivative sketches to choose from and asked which is the correct one. In a case like that, it's a really good plan to actually quickly underneath the function they give you, sketch in your little XY axis and go through the procedures that I've shown you in this video to help you decide which of the diagrams they give is the correct one for the derivative sketch.